Oh God, I grant one, don't I? Well, good morning, everyone. Let's get started. We were looking at, and we still are, the first one of our homework group of questions, and it was the unit circle, if you can remember. And if I kind of repeat kind of where we left off, if you take your typical unit circle, you'd think by the number of unit circles I've drawn in my life, I would be better at it, but everyone's unique. Right, there's your unit circle. Right, you've got your usual X and Y intercepts that are easy to identify. And the equation of a unit circle is that, because the radius is 1. And what else do we know? Oh, and don't we call any of the points from here to here the first quadrant, and this is called the second quadrant, and this is called the third quadrant, and this is called the fourth quadrant. And in the first quadrant, all the X and Y's are both positive. In the second quadrant, the X's are negative, but the Y is positive. In the third quadrant, the X and the Y are both negative values. And in the fourth quadrant, the X is positive and the Y is negative. And the reason that we might want to know that is that a lot of homework questions say, I'll give you the X coordinate, you tell me what the Y coordinate is. And normally when you do that, you have two choices, right? Plus √3, minus √3, you know, that kind of thing. And you have to kind of know which one to choose. So let's pick one right off the bat. And this one is question 7, just as an example. In this particular one, you're being told that the Y coordinate of P is -3/5. No, I just climbed the wrong place. It's negative, try that again, it's -5/13. And you're told that it is in the fourth quadrant. And we're being asked to find the X coordinate. Right? So my normal way of writing that question would be to write something like this, ... -5/13, right? And we're trying to find that guy, right? Pretty standard. You do x² plus y² equals 1. That becomes x² plus -5/13 equals 1. If you square -5/13, you basically are positive. You get 25/169, and you get to a line that looks something like that. And the next couple of lines are pretty standard, aren't they? You're basically trying to find X, and we use that as long as you do it to both sides, it's okay rule. So would you agree you subtract that ugly fraction from 1? Now, if you have problems with fractions, because sometimes the fractions are just so big and messy, it's hard to keep track of them. If you take 1 and subtract that, you go 1, take away 25/169. You see, I'm just typing in as a calculation. Now, when I hit enter, a decimal's going to appear. Don't worry, we can fix it, right? You are not allowed to use that as your answer or even part of your working. That's not the guy we want. We want exact values. So just hit the math button and choose number 1. Basically, take your answer and make it a fraction. And now, you see that? 144/169. So actually, fractions are pretty easy, aren't they? If you let the TI-84 do the hard work. So subtracting 25/169 from both sides, I now get that guy. Great. Okay. Now, just like we did yesterday, what shall I do to both sides to find X?
Square root.
And I'm putting in a lot more working than you typically would do, you know, if you were doing this as homework. And so what we're left with is, of course, a choice, right? But I can simplify that as the square root of 144 over the square root of 169, which I can do. Okay, this guy is in the fourth quadrant, remember? So only one of these two is correct. So I may have to drop this down a little bit. If you're in the fourth quadrant, right, you're in here. Isn't the X coordinate going to be positive when you're in the fourth quadrant? Do you see that? Fourth quadrant, X is positive, which means that my answer is positive. And that guy is 12, and that guy in the bottom is 13, so we didn't even have an ugly answer. So the missing X coordinate is 12, 13. How we go? So if I give you one of the two coordinates, either the X or the Y coordinate of a point in the unit circle, and I give you a little piece of extra information, like which quadrant it's in, or the X is positive or whatever, do you feel comfortable you could find the only answer that's possible, right? There's only going to be one solution, missing X or missing Y. Do you feel comfortable about that? Okay, so that kind of takes us through a bunch of questions. Let's see how far that takes us. Now that takes us to question 10. So we should be able to do everything up to question 10 right now. Now we're moving on to something a little bit nearer. We're going to look at these guys, and they're called terminal point. Now I have, please, I printed it. Please don't lose it. Yay, I got it. Okay. What I have here is a copy of a unit circle, but it's got more information on it than just the blank one I started. In fact, it's got an awful lot of information. Some might think too much. But the thing I want you to focus on right now is, do you notice that these key points, they're telling you the coordinates? So can you imagine you drew a unit circle, right? And you start at the x-axis, and it seems a bit strange, but you always do it this way. You start at the x-axis and you move in an anti-clockwise direction. You'll get to an angle like 30 degrees, or you'll get to an angle like 45 degrees, or an angle like 60. So at the angle of 60, you see that the point there has coordinates a half root 3 upon 2. Right? So you see how this thing works. Now, these points at the end, these are called terminal points. I guess you might say the end of the line, right? Terminal, right? The end of the line points. So if I said to you, or at least they would say to you, for the angle T equals 30 degrees, what would the terminal point look like?
5 or 6. Well, is it the coordinates?
It's yeah. So it's a point. Think of point as meaning coordinate, right? The terminal coordinate. And so you would write down that guy there, right? So as long as you've got this thing in front of you, can't you tell me the terminal point, right? Does that make sense? So you don't need to worry yet, you know, where these guys came from. Somebody spent a lot of time and hard work to do it for us, right? We're just going to say thank you, right? So what would the terminal point for 90 degrees be? So terminal coordinate, if you like that word instead.
0, 1.
Agreed. And what would it be for 4/3 pi? If you can read my screen at this rate. 4/3 pi, the terminal point. Oh, it's kind of hard to read. I'm pointing at it.
Is it negative 1/2 and then negative square root of 3/2?
God, your eyesight's better than mine. Yes, it is. Right. I think I've put one of these guys already in Canvas. So you may want to go to Canvas and print this, or, you know, at least enlarge your screen or something, right? So you can use it when you come to do that. Now, I could turn the question on its head. I'm going to tell you the terminal point, and you tell me what the angle is. If you can read it, hopefully you can. Is there a way? I don't know if this is going to work. I'll try it anyway. That does work. God, I got lucky. Does that help you read the answers?
Yes.
Okay, so my hand will shake a little bit. Suppose I tell you the terminal point is 1/2, comma, √3/2. What would the angle be?
60 degrees.
Right. So you can use this unit circle, can't you? In two directions, right? If I tell you the angle, you can give me the terminal point. If I tell you the terminal point, can't you also then tell me the angle? It kind of makes sense in both directions. You comfortable with that? Right. Now, the next thing you're not going to be able to do, because this is going to have to disappear, I want to show you what that question looks like in your homework, so you get a better idea of what's expected of you. Right. What you have here is a little baby version of that unit circle. Have you noticed that almost all the points you're not told about them, right? But couldn't you, if you had my big book, couldn't you go and find out who they are, right? Now, if they tell you that t is 0, the terminal point has coordinates, and you're going to have to trust me, 1, 0. And I just made a mistake there, 1, 0, to see how WebAssign wants you to write it like that. Right. Now, they want you to go through the thing in increments of pi/6. So that guy there is pi/6. The next one is 2 pi/6, but 2 pi/6 is the same thing as pi over 3. Now, I'll try and do that a little bit quicker on the next one, right? So down this column, I'm going to put all the angles. Essentially, it's going to be all these angles here, right? These guys here. Right. So 1/6 pi, 2/6 pi. The next one would be 3/6 pi. What simplified version will 3/6 pi become?
Pi over 3.
Pi over 2, right? Half pi. So you hit the fraction button.
Pi over 2, yeah.
Yeah, pi over 2. Hit the fraction button, and then you go to Greek letters to type in pi, because you have to write down pi, right? There we go, pi. And then click on the bottom and put 2. So we're just going through the mechanics of where the buttons are. So do you notice that pi is hidden on this little thing here called Greek? If you hear a noise in the background, my puppy has decided to eat an empty Pepsi bottle, and she loves it because they make noises. Right. But okay, so what's that? 1/6, 2/6, 3/6. The next one would be 4/6, which is 2/3. So that'll be the last one I'll do at this time. So you hit it, and you go 2 Greek letter pi over 3. And then you write down what the terminal point is, right? So pi/3, I've got it in front of me here, is 1/2 √3/2. So I want 1/2. And then I want √3/2, so a fraction, square root of 3, upon 2.
Do we need to memorize this? Like the unit circle?
I would just print one and have it in front of you. But it's real, you're going to use it so much that even if you don't want to, you'll start memorizing some of them because you end up using them so many times. You don't need to, but I would suggest strongly that you do. Right. Are you comfortable a bit? Basically, this table's going to be coming from this guy. Right. So that's what's expected of you in homework. So now I want to take a little side issue and explain why there seem to be funny angles. Remember that 30 degrees, which everybody, I think, knows degrees, right? If I said to you 60 degrees, you kind of know what it looks like, right? That is degrees. But there are actually 2 measurements that are used for angles. The one that almost everybody who knows anything about angles knows is degrees. For instance, 30 degrees. How many of you have heard of an angle measurement called radians?
Mm-hmm.
You heard of it? Some have, some haven't. It's not maybe as common. But radians, in fact, if you ever go in and do calculus, all angles, virtually every angle I can think of, is always done in radians. So let me try and show you the connection between the two with one of my really bad, oh, I don't need to, I've got this guy, and I'll bring him up close. 30 degrees is the same thing as pi upon 6 radians. 45 degrees is pi upon 4. 60 degrees is pi upon 3. Now, if you look, you can see these angles. These are the nice ones. And then on the outside, you've got the equivalent angle in radian measurement. So how can we kind of merge those two together to see how they're connected? So here's my unit circle. Now, when you do degrees, like a clock, you start at the x-axis, right? And you go anti-clockwise. So that's about 30, right? That's probably what, about 45? That's about 60. That's about 90, right? It's like a clock turn. That's degrees. Angles that are measured in radians are measured in a quite different way. You start with the x-axis and you travel along the outside. And if you go around a unit circle, right, can you imagine going all the way around that? The circumference is 2 times pi times the radius, and that's 2 times pi times 1. So the circumference is 2 pi. So if I started here and went all the way around the circle, would it not be 2 pi? You agree the distance? Now, if you wanted to do an angle, let's say this angle here, the radian measure is how far the little ant would walk starting here, right, and going there. So if that was like 30 degrees, for instance, right? What would 30 degrees look like as radians? Well, there's a calculation that you can basically do to figure that out. In radians, one complete revolution, right, start to finish, is 2 pi. And in a circle with degrees, isn't 360 degrees the same thing as one revolution? So far, so good. Now, what number of degrees would pi radians be?
180.
180, would it be half of that? Okay. Now, if 180 degrees is pi radians, what do you think 30 degrees would be? What fraction for pi?
6.
1/6. Can you see where that 1/6 pi came from? And all the other ones that you might or might not be able to see here, like 11/6 and 2/3. Basically, that 2/3 means if you started here and you walked to there, that would be 2/3 pi. It's about 3, 6. That's about 2.1 units, right? That's how far you would walk. So I said there's a formula for it. So let me write it down. If you want to know what the radians are, you take the answer in degrees and divide it by 180. Stick a pi in there. Right, basically 180. Can you see where this is coming from? And you know there's going to be a pi, right? Let's try it then. We know the answer, but let's see, pretend we didn't. I want to know what 120 degrees is in terms of the radian. Well, it's going to be 120, right? The answer in degrees, divided by 180 by pi. And you can cancel that down. It simplifies down to 2/3 pi. So if I'm correct, won't 120 degrees be the same thing as 2/3 pi radians? Agreed? Let's check it out. Is 120 degrees 2/3 pi radians? Are you a little bit more comfortable about the radian measurements now? It's just another way of telling you what size the angle is. Instead of doing it like 360 degrees is a circle, they do it by measuring the distance that you would walk around the outside. It's just another way of coming up with the same kind of piece of information. And radians are going to be big for you as well. So we're going to do at least 50%, probably more likely 60-40, where 60% of what you do is in radians and 40% of what you end up doing will use degrees, right? So it's going to be at least 50-50, but probably more like 60-40. Nothing that you need to know for the exam, but I want to tell you anyway, because I think it's interesting. And that is, because you might have thought about it, maybe you haven't, why has a circle got 360 degrees? If you think about it, it's a kind of weird number. Shouldn't it be 100 degrees? Couldn't you take a circle and just break it into 100 equal parts and call that a degree? Wouldn't that be more typical, right? Decimal system, right? Shouldn't it be 100? But there's not, there's 360. Why is there, and this is going to have the same answer. Why are there 60 seconds in a minute and 60 minutes in an hour? Why isn't there just make the second shorter or something? Why is there not 100 seconds in a minute, right? And 100 minutes in a different kind of hour, right? Why is there not 100 hours in a day, right? Why are we not decimal? Why is time in weird numbers, right? Why is there 24 hours, right? You never thought about those. And you might think, well, there must be a reason. It can't be just somebody got up one day and said, that's a circle, 350, 360, 360, and they just picked a number. That's not how it happened. Time and the funny units that it uses, and 360 degrees, and a few other strange things, all happened because of the Babylonians. Way over, where Syria is, and Iran, that part of the world, right? Babylon, way back in biblical times. Right? And the people in Babylon counted in base 20. Sorry, counted in base 60. What does that mean? Well, when a Babylonian wrote down numbers, they didn't do what we did, 2, 3, 2 lots of 10 and 3 units. They counted in clumps of 60. So if a Babylonian wanted to say 64, they would say 160 in 4 units. Now, since they guys were one of the biggest civilizations out there, can you imagine that when they started working on time, since they already counted in 60s, doesn't it make perfect sense to have 60 seconds in a minute and 60 minutes in an hour? Didn't that seem very natural to their wake up? They also, because they were fascinated with time, because it's to do with when to sow your crops, right? So knowing, a year and how you split it up was important to them. They also decided that there was 360 days in a year. And that's why there's 360 degrees in a circle. He thought of a circle being the year, a cycle, right, for the year. Now, they were really clever people. They knew they were wrong, right? You know that there's 365 and a quarter days. They knew they were wrong. It didn't take them many years to figure out, why is it freezing and it's July? That kind of thing, right? Why is things not working? They knew they got it wrong. And they actually knew that there was 365 and a bit days. They were that good. But they didn't want to break up that perfect 6 lots of 60, right? They got in their head 60 is such a beautiful number. Everything should have something to do with 60, right? So what they done was really clever. They still had 360 days in a year. And at the end of the 360th day, they just had an equivalent of a big party. They just had 5, days of, it didn't have a name day, right? It wasn't part of the year day. They just had it. And then, it's like New Year's Day, right? They just had it for longer. And then they started and they had 360 days. Isn't that a great way of fixing a problem? Don't fix your calendar, just fix the way that your year would go. So if you're wondering where the 360 came, and I know I've diverged, but it's I think it's interesting, so it's kind of going on. So what kind of questions are you going to be asked that uses this fella? Well, they are pretty standard. I'm looking at a question right now. T is 2/3 pi. Right, so the angle is 2/3 pi. What is the terminal point? What are the terminal coordinates? 2/3 pi.
-1/2 and a square root of 3/2.
Right, you basically just read it off the chart, agreed? If I said to you T was 3/2 pi, wouldn't you be writing down the terminal point 0, -1? If I told you that the terminal point was √2/2 minus √2/2, wouldn't you be telling me that the angle T was 7/4 pi? Have you noticed that everything is in radians, right? They're not asking, for the most part, anything in degrees. So far, so good. Now we're going to try something that might seem a little bit strange, but it's actually not that strange at all. There's a little baby unit circle. Actually, it's one of my better circles. Now, if you start here, it's 0, right? You start there and you don't go. Wouldn't that have an angle of 0 degrees, 0 radians? Can I tell you that this angle up here is pi upon 2? So I mean the angle is pi upon 2, not the coordinate, right? This one over here is pi, and this one down here is 3/4 pi. What would you get if you went round the circle and back to the start? What would the angle be in radians if you started here and you went all the way around and you finished here?
2 pi.
2 pi. That makes sense? 360 degrees, 2 pi. Right. Now, suppose I told you that I had an angle T, and the angle T was 7/3 pi. Seven thirds is not in my unit circle, because isn't 7/3 bigger than 2 pi? You agree?
Mm-hmm.
So how do we get a terminal point for an angle that is bigger than 2 pi, bigger than 360? Well, if you subtract 2 pi away from 7/3 pi, you are left with 1/3 pi. So basically 7/3 would be go round the circle once and then go an extra 1/3 pi. Does that make sense? So now that you know that guy, can't you then get the terminal point, which is the coordinate, there we go, 1/2 √3/2. So for T equals 7/3 pi, its terminal point would have been whatever that is, and that is 1/2 √3/2. So we are going to be given angles that are bigger than 2 pi, and we're going to be asked to find what the terminal point is. And the way that you're going to do it is take the angle and just subtract 2 pi, and what's left will give you the answer. They even have a name for this small angle. One of its names is called the reference angle. So if you want to get an angle in the 0-2 pi range, right, the 0-360 range, right, the original angle was too big, but you wanted to find out what it was the same as, right, between 0 and 2 pi, we call that answer the reference angle. Right? Let's try another one. Oh, shooting space. There we go. 14 thirds. I fixed it. 14 thirds pi. And would you agree that's too big? You agree it's more than 2? Right. So we want to find what I'm going to call its reference angle, because once I know that, can't I now get the answer, which is what's the terminal point? What do you think I should do to 14 thirds? Okay, so I'm going to go on my calculator and do 14 thirds take away 2. I don't need to worry about the pi. Would you agree it's still too big? It's 2.6 pi, right? Still too big. So what do you do if it's too big? What do I do now?
Subtract another 2 pi.
Okay, so now, won't I eventually get a number that isn't too big, right? In this case, I've got that one. But I want the answer in exact, but can't I just do number 1, turn my answer into a fraction? And guess what? I now have what it's equivalent to. It's now equivalent to 2 thirds pi. And once I know that it's 2 thirds pi, can't I now use my unit circle and find its reference angle? Terminal point, I should say. See it? So 2 thirds pi would be negative half root 3 upon 2. So that's how you're going to cope with questions where the angle that they give you is too big. Right? So if it's bigger than 2 pi, it's too big. Keep subtracting 2 and another 2 and another 2 until you get to the point where it's in the range 0 to 2 pi. Of course, they can do this to you as well. Angles can also have negative values. This is negative 1/4 pi. I'm going to try and show you what that looks like. Normally you start and you go this way, don't you? That's the way you normally measure angles. So if you have negative 1/4, you start there, but you go clockwise. And so it would roughly be about here. Does that make sense? What a negative angle means is just go not anti-clockwise, but clockwise. I still need to know what its reference angle is, right? Its reference angle is, you know, one of these guys. What do you think you do when the angle that you start with is too small? If it's negative.
Add 2 pi.
You just add 2 pi. And I could do that in a calculator, but can you trust me that it ends up being positive 7/4? Doesn't that look reasonable? That is roughly where 7/4 is. And you go and now you say, ah, gotcha. So the terminal point would be this one. So they can give us really any angle they like now. Can't you find what the terminal point is? Right? If they give you an angle that's too big, aren't you just going to keep subtracting 2 pi till you get a reference angle that works? If it's really big, aren't you going to subtract 2 pi maybe twice and then get the angle? If it's too small, if it's negative, aren't you going to add 2 pi until you get a reference angle you can use? And let's pick a horrible one of that version then. Negative 13 halves. Right. You agree that's really low, right? Really small. Now, couldn't I just keep adding 2 until I get the right answer, right? But if you kind of know that it's going to take more than 1 2, couldn't you add 4 or add 6 just to save some work? Does that make sense? Right. How much do you think would be a good number to add to this one? In just one big go. See if you can do it. Two's not going to work. 4, 6, 8, match. Come on, go for it. It's a guess. 2, 4, 6, 8.
I would say, yeah.
Come on, stop telling yourself out of it. What were you going to say?
I was
8.
gonna say 14.
Okay. Well, I'll add 14. Oh, too much. That's okay.
Let me go back the other way.
Well, take away 2, take away 2. Hey. Take away 2. Yeah. Didn't we finally get an answer between 0 and 2?
Yeah.
Yeah. So it's not a biggie, is it? Can you just keep adding, taking away if you overshoot it, take off a few? The bottom line is you get 1.5, which we will make into a nice fraction. And that fraction is 3 upon 2 pi. And 3 upon 2 pi has a terminal angle of 0, -1. Keep saying terminal angle, and you can say terminal point. Do you feel comfortable about finding these terminal points for any angle in radians, whether it's the nice ones which are already in your unit circle, right? That's any guy between 0 and 2 pi. If it's too big, you know, like 17 thirds pi, or if it's too small, like -13 pi. Do you feel comfortable about the process? Do I need to do more, or are we good? We're good, okay.
I think I understand it just fine.
Good, that's what we want. I'm just looking through these questions. There's quite a fun. Yeah, 19, 20, keep going, 21. I've already done this next one, but basically what we've done right now will get you up to 21, right? So I think it's from whatever it is, 10 to 21 we're covered. So I've already mentioned this guy. We're going to look at reference number. That guy's 5 pi. Isn't he too big? Right? Anything that's not between 0 and 2 pi needs to be fixed, right? If you keep taking 2 away from that, you're going to get a new guy called the reference number, which is pi. So here's a little notation for you. If you put a little line above something, you say it out loud as T bar. That means the reference number. So the original angle is 5 pi. The reference number T bar is 1 pi. You're comfortable with the notation? It saves you having to write the word reference number equals pi all the time, isn't it? Just nicer to write that down equals pi. What would you do for a reference number like -3/2? What would its reference number look like? So we've actually been doing this today. We've just given it a name that we're calling it a reference number, and we're calling it T bar. What would you do to this guy to find its reference number?
Add 2 pi.
And can you trust me on that it's pi upon 2? Right? -3/2 add 2, you get +1/2. Are we good? So let's throw a weird one in. Ooh. 17. Oh, by the way, 2 pi is roughly about 6.28. So isn't that too big? And what do you do when it's too big? Well, don't you subtract 2 pi from it? Great. So let's see what we got. 17, take away 2 pi. Oh, that's 10.7. That's too big. Okay, I'll take away 2 more pi. We got that one. That's okay. But I don't write that decimal. I just write 17 and I took away 4 pi. That is a really weird question. Don't expect to see many of them. You see, that's a really special case. I don't want to know the decimal. I don't want to know it's 4.433 and all that. I want to know how I would get it. Thankfully, almost every question you do looks like that. Are we okay with that? Most of them are going to be this, but if it was 8, wouldn't you just do 8 take away 2 pi? That would be enough. If it was 100, you may have to take away 20 pi, but whatever. Not that I would ever do that to you. I just saw a weird question. It's actually a trick question. That's why I think it's weird. What is the reference number for the angle 1/3 pi? It's a trick question.
1/3 pi.
Is it?
Yeah, it's 1/3 pi. Is that not a trick question?
I was
Right?
just gonna say, isn't that a reference number?
Yeah, it is. It already is a reference number. So I just looked at it and I thought, why did they do that? I guess they did it for the reason that it makes you think, okay, some angles I don't need change, right? Some angles are fine the way they started life off. And that's basically 23, 24. Well, let's pick something from 25 then. And we're going to find reference numbers. And this one I'm going to pick is that guy. So we're going to find its reference number. What do I need to do to this one? Well, it's too small, isn't it? It's negative. And what do you do when something's negative?
And
2 pi.
Okay, so -7/6, add 2 pi. And that's good. I'll make that a fraction. And the answer ends up being 5/6 pi. Are we good at finding these reference numbers now? If it's too big, take away 2, take away 4, take away 6, whatever it takes. If it's too small, add 2, then add 4, 5, until, you know, everything's good. And then they put the package together. So questions 26 now gives you an angle like 11/3. And they ask you to find the reference. And then they ask you to find the terminal point, right? Okay, 11/3 pi. Is that good to go or is it too big?
Too big.
Too big. Can't you just say 11/3 is what, 3 and a bit? That's too much, right? So 11/3 then, take away 2, and then make it a fraction. And so that's 5/3 pi. So that's the first answer. And the terminal point, well, where's my guy gone? I lost it. Oh, there we go. And 5/3 pi is here. So the terminal point has coordinates 1/2, -√3. 1/2, -√3, 1, 2. That's kind of putting all the bits together, right? How about this one?
be 90 degrees.
I think someone said 90 degrees, which it is. You're right.
So it'd be 0, 1.
And the answer is 0, 1. In fact, it isn't.
Just be.
It's another one of those I don't need to do anything to you questions. So that the reference number is the same as the original angle, right? And 0, 1. I think this is going pretty smoothly. Are we good?
Yep, I am.
Okay, I'm good too then. But it just check some things here. And we're pretty much, well, while I'm checking this, will you put your last name only down for attendance? That way when I'm finished, we're good to go. Okay, now, there is one last angle that we sometimes need to find. So I won't bother the unit circle, right? Can we pretend that this angle here is 5.3? Okay. So T is 5.3. Won't T part, that guy also be 5.3. Not worried about that. Now, I want an angle over here. And this angle over here is going to be 3/4 pi. There's an angle that we want to find sometimes, which is basically the angle that the original makes with the x-axis. So how big is that little angle there?
Wouldn't it just be 30 degrees? The same,
In radians, what would
pi
that
over 3.
check it again, that's 3/4. So if that's 3/4,
1/4 pi.
yeah, wouldn't that be 3/4 take away that? So it's 1/4 pi. Suppose oh god, this picture's getting really messy, I apologize for that. Suppose I told you that that entire angle from there to there, right, was 4/3 pi. Right. So you start there and you go to there and you get 4/3 pi. The angle that we want to know about is this shaded angle in here. What would that angle be? So the angle that the original one makes with the x-axis.
1/3 pi.
1/3 pi. So let's show you where those calculations are coming from. See that first one? This one up here? You take pi and you subtract the 3/4 pi from it. On the other hand, see this one here? Don't you take 4/3 pi and subtract pi? Have you noticed that you either add or subtract pi? Right, it's a difference. Pi take away the thing or the thing take away pi. That's how you're going to get any of these angles. If you want this one over here, isn't it going to be 2 pi take away the angle? When I see tomorrow, we'll spend more